So here we are starting the second day of coordinate proofs. First day we talked about our different shapes and each property that goes with those shapes. We talked about our formulas and we'll readdress those. So starting our second page, we have a slope formula, which is y2 minus y1 over x2 minus x1. It's always the rise over the run. The rise is the y-axis, up and down. Running is right to left. That's the x-axis. Midpoint, sometimes you put a D in there, so midpoint is going to be the average of the x's. So you add the x's together and you divide by 2. You add the y's together. Doesn't matter, but typically you would follow y1 plus y2. You're just adding, so it doesn't matter what order you add them in. And then there's a distance formula. So you subtract the x's. A lot of times we say x2 minus x1, thinking that x2 might be a bigger number. So then you subtract x1, you'll still have a positive result. Doesn't matter as long as you're consistent throughout the problem. y2 minus y1, you've got to be in the same order, whatever you decide. So that's our distance formula. So just to make a good pattern here, I would suggest to always attempt these problems in the same pattern. So let's graph it first just to give us an idea of what we're looking at. -4, now look at these. They're got different scales. It looks like your x-axis goes by 2s and your y-axis goes by 1s. So this is actually going to make the shape look different than it actually is. But 2, 4, and then 1, 2. -2, 1, 2, 3, 4, 5, 6, 7, 8. So this was our J. This was our K. 2, 4, 6, 8, 10. 1, 2, 3, 4. And then 8. 1, 2, or 2, 4, 6, 8. Down 2. Doing this with a straight edge would probably be the best option. Use an ID card, but if you take your time, you can make those marks nice. So 10, 4 was L, and 8, -2 was M. So we want to label our picture there, our graph. Now, it doesn't really matter which one we start with, but if we want to figure out if it's a parallelogram, let's first do the midpoint. Are both diagonals going to have the same midpoint? That is the question. You can probably approximate the midpoint pretty well just by drawing in the shape, but we want to do the calculations to verify that. So we're going to do midpoint. We are going to test for parallelogram. Okay, that's what the midpoint does. If they have the same midpoint, the diagonals have the same midpoint, then it's a parallelogram. So JL, you need to be sure to use the correct letters. So we're going to use the midpoint of JL. So the midpoint formula is to add the x's. So J is -4 plus L is 10 over 2. And the Y values are 2 plus 4, like that. Okay, so this is going to come out to be 6 divided by 2 is 3, and 6 divided by 2 is 3. Looks like 3, 3. 1, 2, 3. 1, 2, 3. That seems reasonable. Looks about where my sketches make that happen. And then we'll test the other diagonal, KM. Now we're going to test KM, and we're expecting it to be at the same location if it is a parallelogram. So you take your x's, -2 plus 8 divided by 2, and 8 plus -2. Notice how I use parentheses around that. So this is going to be 6 divided by 2. And this will be 6 divided by 2. So yes, we get 3, 3. Same diagonals, proves it's a parallelogram, or same midpoint. The diagonals have the same midpoint, so that proves it's a parallelogram. So JKLM is a parallelogram. Okay. That's one thing we know for sure. Now the next test, if you want to look back on the opposite side, the first one we were testing if the diagonals bisected each other. The next one we could test is if the diagonals are congruent to each other. Well, we can look here. I don't expect them to be congruent to each other, but remember, right to left is not with the same scale. So it doesn't look like they're congruent, but they might in fact be congruent. We need to test this out. So we're going to use the distance formula. And this is going to test for, it's testing for congruent diagonals, but this is going to test if the shape has right angles. Test for right angles. Okay, that's what congruent diagonals would give you a rectangle. Okay, so our first one is going to be JL. So with JL, we use our x's, so -4 minus 10 and 2 minus 4. We square those. So when we calculate the -4 and -10, we get -14 that is squared. And when we do 2 minus 4, we get -2 that is squared. And we know that 14 being squared, even if it's negative, being squared is 196. -2 being squared is 4. So that gives us 200. Now, you could leave it with that if you're just comparing, but we like to practice our simplifying. So 200 can be broken down into 2 times 100. We know the square root of 100, so we have 10 root 2. So that's a simplified form. That's our distance. We could do a decimal, but really all we're going to do is compare it to the square root of 200. So let's now see what km is. It doesn't look to be the same length, but because the scale is different, it just might happen. Let's find out. So the k, I'm taking the -2 minus 8, and 8 minus -2. That's fun. All right. Now, this is really important. Don't fall into this trap. I did not say -2 minus 8 and 8 minus -2, but I did the x's, which was -2 and the 8. Then I did the y's, which was 8 and -2. So it could be misleading if you were looking at the numbers incorrectly. All right. So here we're going to have -10, and we square that to give us 100. Here we're going to have 8 minus a -2, so that's 8 plus 2. That's 10 squared is 100. And yes, that is going to give us square root of 200, which we know breaks down into 2 times 100, which is 10 root 2. So both diagonals are congruent. And if the diagonals are congruent, it's showing JKLM is a rectangle. It has 4 right angles. If the diagonals are the same length, it has 4 right angles. Let's take a look at our quick picture that we drew the first day. If the diagonals are the same length, then it's going to have 4 right angles. That only happens in a rectangle. Remember, a square is a type of rectangle. All right. Now the last one we're going to have to look for is the slope. We've got to figure out if these are perpendicular to each other. They don't particularly look perpendicular, but remember the scale is different, so that might throw it off. So we're going to test our slopes. Okay, we're going to do the slopes of the diagonals. So JL, when we do slope, we do rise over run. So we're doing the y value minus the y value and the x value minus the x value. That gives us -2 over -14, which is 1/7. Okay. So let's see if that makes sense. We went up 1 and over 2, 4, 6, 7. Up 1 over 2, 4, 6, 7. So yeah, that actually worked out. You could just count your slopes. And the other one, km, we take the y value, which is 8, minus the my value, which is -2. K's x value is -2, and m's x value is 8. So this is 10 over -10. So that gave us -1. Well, let's test this and see what happens. We went down 1 over 1, down 1 over 1, down 1 over 1. Remember, it's twice for the x's. So that's why I'm only going over a half. And it looks like if I follow that same pattern, I land right on it. So that seems to be a slope of 1, even though it's not following the diagonals perfectly between the coordinates. It does follow that because the scales are different. So this shows diagonals are not perpendicular. Not perpendicular. So not a rhombus. And in this case, since we know it's a rectangle, this really shows it's not a square. So this shape here, we determined was only a rectangle. JKLM is a rectangle. And we gave our description of why, because the diagonals are congruent and the diagonals have the same midpoint. So we're going to come down here to our next example. This doesn't have scales that are different. We would assume if it's not labeled that they go by ones in every direction. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3. That looks like that would be W. And then we have -2 and 1. That should be X. And then -1, 4. That should be Y. And 5, 1. That should be Z. Okay, so we drew those out. All right, now I'm going to show you a little bit different way to calculate some of these. If we are going to first test the midpoint, and when we do midpoint, this tests for parallelogram. Okay, now in a coordinate proof, we would need more to do with numbers. So that's why I'm not going to just draw them in for us to approximate the answers. All right, but they can give you the idea if they're the same or not. All right, so we'll do our calculations for midpoint. So we're doing the midpoint of XZ. XZ, we take our X's, -2 and 5, and divide that by 2. And then take our Y's, 1 and 1, and divide that by 2. So that looks like we get 3/2 and 2/2. So that looks like our midpoint of XZ. Then our midpoint of YW, we take the Y value, and we take the X of the Y, and we add that to the X of the W. And then we take the Y of the Y, and we add that to the Y of the W. So this is going to be 5, 6 plus a -1. So that's 5 divided by 2. And this is going to be 1 divided by 2. So that clearly looks different. Let's see if this makes sense to these. So it looks like we go 2.5. Let's see, 2.5 and up. That looks to be about the midpoint of that one, YW. And 1.5 and 1 seems to be the midpoint of XZ. So they are in different locations. All right, so this is not a parallelogram. Midpoints are in different locations. So WXYZ is not a parallelogram. So if it's not a parallelogram, then it's going to fall underneath one of these other two categories, either isosceles trapezoid or a kite. We talked about what a kite was, and this would be what an isosceles trapezoid was. I'm kind of betting the shape kind of looks like that, but this is a possibility, and this is a possibility, neither of which are parallelograms. So the next thing we're going to do is look at the distance formula. See if the diagonals are the same length. So if the diagonals are the same length, here with XZ, we're going to find distance. Test for, let's see what we're testing for here. If we have midpoints that are different, but the distances are the same, then we would expect it to be an isosceles trapezoid. If the diagonals have the same distance, then it's an isosceles trapezoid. If the diagonals are perpendicular, they're not going to be congruent. That's going to make it a kite. And maybe it'll have none of these. So it'll be nothing. Just be a quadrilateral. So let's see what we get. We're going to test for an isosceles trapezoid. That's what this would be doing the distance. Now, since we know it's not a parallelogram, it might be an isosceles trapezoid is what it kind of looks like. These slopes look kind of weird. You think that they'd be kind of slanted at the same. So I'm not thinking very positive about this. But XZ, well, since it's horizontal, we can count it. 1, 2, 3, 4, 5, 6, 7. That's 7 units. No need to do a crazy distance formula if it's very clear what that would be. And then YW. YW, the Y X value is -1 minus 6. And the Y values of the Y are 4 minus a -3. So that's giving us -7 squared. That's 49. This gives us 4 minus a negative, so 4 plus. So that's 7 squared is 49. So this is going to be 2 times 49. So this is 7 root 2. Well, it's almost 7, but not quite. It's times root 2. If we wanted just to compare that with something we're more familiar with, we could look at 7 root 2, and that's well above 7 because root 2 is a value of 1.414. When we times that to the 7, that's where we get that 9.8. So it's considerably longer. So W, X, Y, Z is not an isosceles trapezoid. We didn't do it because of the way it looks. We did it because the calculations didn't support it.
Mr. Weber, so if the distance formula, when you use both the distance formulas for both of the points, and then so like if they don't match up, that means the diagonals aren't congruent, right?
Correct. The distances would have to be the same for the diagonals to be the same length.
Okay.
It means different things in different situations. If we had a parallelogram in our first test, then the diagonals being congruent would mean it's some sort of rectangle, either a rectangle or a square. Since we knew it was not a parallelogram, that's these two categories, then the congruent diagonals would have verified it was an isosceles trapezoid. In this case, it is not. And I don't think this kite thing is going to work out for us either. But because in a kite, your consecutive sides have to be congruent, and they're clearly not congruent. This guy's relatively short, and this guy's really long, and the scales are 1-to-1. So I'm not expecting this to come out to any favor. So here we're going to look at slopes. That means we are going to test for a kite. Now, to help speed things up for you, we're going to look at the slope of xz. We could do the calculation, but we can also just count on our grid. We see that we rise up nothing and we go over 7. So our slope is 0/7. Then we can look at YW. And YW, we just have to be patient about this one. We're going up 1, 2, 3, 4, 5, 6, 7, and going over 1, 2, 3, 4, 5, 6, 7. So it's rise and run. One of those would be considered negative. I went to the left with my run, so that's why I made my run negative, but that's a slope of -1. Slope of 0, slope of -1, those are not opposite reciprocal. So these diagonals are not perpendicular. All right, so WXYZ, we know that it's not a parallelogram. It's not an isosceles trapezoid. It is not a kite. We're going to call WXYZ is quadrilateral. It doesn't have any of the special qualities that we would be looking for in those other shapes. Now we'll move on to our next example. We're working with quadrilateral ABCD. So look again, your scale is different, so it's going to throw off the way that it actually looks. This is where the calculations are really important because it isn't what it looks like. Let's put it that way. So A is -8. 2, 4, 6, 8 for the x's, and 1, 2, 3, 4 for the y's. 0, 6, 1, 2, 3, 4, 5, 6. 2, -2, and 2, 4, 6. 1, 2, 3. That's weird. It had a better grid than that. Okay. All right. So when we just look at that, that kind of looks like a parallelogram, but I'm not going to trust that. We are going to do the real calculations here. Let's be sure I got my points right. -8 and 4, 0 right and left and up 6, 2 to the right and 2 down, 6 to the left, 2, 4, 6, and down 1, 2, 3, 4. All right, so that looks like that's what we've got. So we're first going to work with the midpoint. And the midpoint is going to test for parallelogram. That's what the midpoint does. If they have the same midpoint, then it is a type of parallelogram. So our diagonals are AC and BD. Okay, so we'll look at AC. AC, when we do midpoint, we add the x's together. So we have -8 and 2 divided by 2. And C is, or the y values now are 4 plus a -2. So that's going to give us -6 divided by 2 is -3. And 4 plus a -2 over 2 is 1. See if that makes sense. 1, 2, 3, and up 1. That's pretty close to where my location is. Let's see about the other one. We just did AC. Now let's do BD. So with BD, we do our x's, which is 0 plus a -6 divided by 2, and 6 plus a -4 divided by 2. So this is -3, and this is 2 divided by 2, which is 1. So yes, we have the same midpoint for both the diagonals. So A, B, C, D is a parallelogram. Okay, because the midpoints of each diagonal are exactly the same. All right, so now let's do the distance formula. Okay, neither of these are vertical or horizontal, so we can't count it, unfortunately. We are going to test for a rectangle. We're testing for those 4 right angles. So to do the distance formula, we have to take AC. So we take our x's for A, which is -8 minus, for C, it's a 2. And then the y's are 4 minus a -2. And then this is going to be -10, that's going to be squared. And negative a minus, or minus a negative, is going to be a plus. So 4 plus 2, which is 6, which is 100 plus 6, which is 106. We could do a decimal, but the decimal is not important. It is just, will the other diagonal be the square root of 106? Yes or no? We could try to break that down if we thought that that was simplifiable, is 2 times 53. I don't see any pairs of the same number in that. So we'll stick with just square root of 106. Now we're going to look at BD. So the B value for the X is 0 minus the D value is -6. So again, that's one of those minus and negatives. And then the Y value for B is 6 minus, and the Y value for the D is -4. So this gives us positive 6 squared, which is 36, and minus a negative, which is 10. So we get square root of 136. So no, diagonals are not congruent.
Wait, wouldn't the other one be 136 as well? Because it's 6 squared. Wouldn't that equal 36 too?
Oh,
Right.
good call. I just put down 6 there, didn't I? It is 6 squared. Good job to check your work. Thanks for pointing that out. Of course it is. All right, that seemed weird, but I appreciate you hunting that down and pointing that out. So this was 6 squared, so that was 36. So added together was that. So the diagonals are congruent. So now we have ABCD is a rectangle. Okay, a rectangle is a parallelogram. So that is all being supportive all the way through. Now what we're going to check is if it's some sort of rhombus. We are going to do slope. And slope tests for a rhombus. Since we're in the parallelogram family, distance tests for rectangle and slope tests for rhombus. It doesn't look like a rhombus, but remember the scale is different. Sometimes that can throw it off. So let's get in here and find out what we have. So we're going to do the slope of AC, and the slope of AC, we're doing y over x. So the y value is 4 minus -2. And then the x values for the A are -8, and the x values for the C are 2. So that gives us 6 over -10, which is 3/5, -3/5. Now we could probably just count this one, couldn't we? It's just kind of tough with the scales being different, but we go down 1 over 1. Let's go down 3, right? Down 1, 2, 3 over 2, 4, 5. Down 1, 2, 3 over 2, 4, 5. So perfect. That lined up just like we calculated. And for the other slope of BD, we can try to count it if you want instead of calculate it. Again, we go up 1 over 1. Let's go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 over 2, 4, 6. Rise over run. 10 over 6. So that is 5/3. These are the slopes are opposite reciprocals, or some people call them negative reciprocals.
You take control of their build pieces. Basically, every build is yours and not.
We know they're opposite reciprocals because we have 5/3 and -3/5. So those are opposite reciprocals. So ABCD is a rhombus. All right, now it is a rectangle and it's a rhombus. Since ABCD is a rectangle and a rhombus, we can call it a square. Perfect.